Hey everybody, so this is going to be our last solving trig equations video, and this is going to be level 3. So in level 1 we figured out how to solve kind of basic trig equations where we got just one trig function equal number, and we also only had like one theta or one x equal angle at that time. And then in level 2 what we looked at is okay, well maybe these aren't so straightforward to solve. Maybe we have to use some identities to solve them, Pythagorean identities, sum and difference formulas, and so on. But we still ended up with like sine of x equaling number or cosine of theta equaling number. Now in this video, why this is level 3 is because what we're going to end up with is we're going to end up with multiple angles, like cosine of 3 theta equals number, sine of 2x equals number. And so this video is just, okay, well, how do we deal with that? The idea is still the same as the first two videos. So to reiterate, we still want to get the equation in terms of one trig function of the same angle. So of that angle being 2 theta, 1 theta, 2x, whatever, we still need to boil it down to single trig function of the same angle. We're still going to have to use factoring or quadratic formula as needed to solve for that one trig function of the same angle. And then what we're going to do, and this will make a lot more sense in the video with actual live examples, consider all values that make the equation true by solving for these multiple angles now. So when you have like a 2 theta, a 3 theta, 3x, or whatever, there's kind of like this little extra step you have to do with it. But let's just see it in live action. So for this example, sine of 2x equals 1 over root 2. We need to know where x lives. So for this particular example, I'm going to use degrees, and I'm going to say x lives between 0 and 360. Now, in general, you need to be given these parameters. It's either going to say, hey, you need to solve for all values, like all angles that make this true. You need to solve for all angles between 0 and 360, 0 and 2 pi, 0 and pi, whatever. We need to have some kind of parameters on our solution. So we want to solve for all of our angles that live between 0 and 360s, which means this problem is going to be done in degrees. So I have my one trig function here, and I have my same angle, it's 2x equals number. So there's no algebra here that I have to do anymore. What I need to do is I need to solve for x. But I'm solving for 2x. So over here on my parameters, because that's great that x is between 0 and 360, but I need to figure out where 2x lives. And so to do that, we're going to multiply everybody by 2. So 2x lives between 0 and 720. Okay, so what we're going to find is we're going to find all available angles between 0 and 720. So 2x then is going to equal, so basically what we do here is we still solve the same, whereas before we would have, okay, well, x equals everywhere that sine of x is equal to 1 over root 2, also known as 2 over root 2. In that case, and we're doing it in degrees, that would be 45, right? At 45, sine is equal to that. Or if we go around the unit circle a little bit further, we see that, okay, at 135, sine of x is equal to 1 over root 2, or again, also known as root 2 over 2. It's the same thing. But I'm going between 0, so 2x, right? 2x. So 2x lives between 0 and 720. These guys live between 0 and 360. So I need to keep going. So let's add 360. So let's add 360 onto this, and that's going to be 405. Let's add 360 to this. So that's going to be 495. Okay. 2x, again, lives between 0 and 720. So I'm going to say this a lot because it's kind of weird. So therefore, we found all angles where sine of 2x then would be root 2 over 2, right? These are the ones we know from the unit circle, but because our 2x lives between 0 and 720, we kept going. Add 360, add 360. So these four angles live between 0 and 720. Okay, now we don't want 2x, we want x, so here's kind of the magic step. let's divide by 2. And this is the step you're going to see on how to tackle these multiple angles. So now we can solve for x, right? 45 divided by 2, and it's just going to get a little weird. 22.5. Or 135 divided by 2. That's going to be 67.5. Or 405 divided by 2, that's 202.5. Or 495 divided by 2, that is going to be 247.5. Okay, so again, to reiterate, what we did is we messed with the parameters a little bit, right? Because we needed the parameters for 2x. Because it was 2x, everybody got multiplied by 2. Okay, sweet. We want to find everybody between 0 and 720 now. Okay, great. Okay, we did that. And then we found where is sine equal to this between 0 and 720. Okay, okay, we did that. Okay, but again, we don't want 2x, we want x. And now look, x, all these x values do live between 0 and 360 now. So magically, we've kind of fallen back into the parameters that we did need. So we kind of artificially blow everything up, and then we like take it back. Okay, and that's going to be the theme of all of these. You like kind of artificially blow it up, and then you like take it back, and you're like, oh, hey, now everything works out the way I originally stated I wanted it to be. Let's see some more. So what about cosine of 3 theta equals -1? And let's do a radian example this time. Let's say theta lives between 0 and 2 pi. So we're going to do a similar process. It's just now everything's going to be in terms of radians at this point. Cosine of 3 theta. So that's great that theta lives between 0 and 2 pi, but everybody needs to get hit with a 3 because we're doing 3 theta. Okay, so again, my parameters change first. Okay, 6 pi. So this is 3 revolutions around the circle. Okay, so 3 theta then lives between 0 and 6 pi, which means I need to find all values where cosine is going to be equal to -1 between 0 and 6 pi. 0 and 2 pi is 1 around the circle, 4 pi is 2 times around the circle, 6 pi would be 3 times around the unit circle. So 3 theta then is going to equal, where does cosine equal -1? Conveniently for us, it's only actually in one spot. It's at pi. Well, pi lives between 0 and 2 pi, that's great, but if I go around the circle again, right, so I went around pi, if I go around the circle again, add 2 pi, that'd be 3 pi, or 3 pi, or, okay, I go around the circle again, basically I just keep adding 2 pi, 5 pi. So this is where cosine equals -1 between 0 and 6 pi. It'll equal -1 at pi. It'll equal -1 at 3 pi. It'll equal -1 at 5 pi also. Basically, once you find the initial value that's between 0 and 2 pi, basically the initial value being the value you see on your unit circle, just add 2 pi until you reach your parameter. Basically, if I added 2 pi again to this, it'd be 7 pi. That puts me outside of my parameter, so no good. So these 3 answers are what I want. And what we saw last time, well, I'm going to divide everybody by 3. So then theta equals pi over 3, or 3 divided by 3 is pi, or 5 pi over 3. And again, notice now, once we're done, pi over 3 pi and 5 pi over 3, these guys are between 0 and 2 pi. So again, what we did is we like artificially blew everybody up, solved, and then we like brought everybody back down, and now we do meet the original parameter for theta, and we've like kind of magically now found everybody that exists between 0 and 2 pi. So let's see a little bit more complicated example. Let's do some kind of solving techniques too. So how do we handle this guy? So we're going to throw in some of that identity stuff that we talked about in our level 2 video. Well, this looks strikingly familiar to me. This looks a lot like the sum formula for cosine, right? It looks a lot like cosine A, cosine B, minus cosine A, sorry, sine, sine B, right? Oh, A must be 2x, B must be x, right? Huh, interesting. And that is the sum formula for cosine. Remember, cosines are opposites for the sines. Okay, well, if that's the case, then this whole guy here boils down to cosine of A plus B, 2x, plus B is x, and this equals 1 over root 2. Again, on your unit circle, you'll see this also as 2 over root 2 as a rationalized denominator. 2x plus x is 3x. So now cosine of 3x equals 1 over root 2. For this problem, I'm going to say I want my parameter to be all values that make it true. So I'm not holding I'm not doing any restraints. There's no 0 to 2 pi, there's no 0 to 360. I want all the values here. And how I'm going to do this, so all values. So, and let's see, radians, degrees, we did radians last time. Let's do degrees this time. So, where is cosine equal to positive 1 over root 2? Or again, also known better as 2 over root 2. Well, 3x then is going to be equal to 45 degrees plus 360k, right? Because we're doing all values. Or it's cosine, so that'd be 315 plus 360k, right? Because I said all values, that's where the plus 360k comes from. Basically, that means, hey, I can just keep going around the circle and I can keep getting values that will make this thing true, and I can do this forever and ever and ever and ever. Okay, but I'm not solving for 3x, we're solving for x. So we hit everybody, and this is important, everybody gets divided by 3. Even that 360k gets divided by 3. Everybody gets hit with a divided by 3. So then x is going to be 15 plus 120. Okay, in other words, x is going to be 15 degrees plus all multiples of 120. So again, infinitely many values. Or 315 divided by 3 is 105. Plus, again, 120k. This will give me all values in degrees that make this true. So we still, what we did here, instead of blowing up my parameters, because we had no parameters in this case, we just straight up solved for 3x, figured out all values of cosine that equaled positive 1 over root 2, and then we divided everybody by 3, including the plus 360k by 3, because we just wanted 1x. Okay, so this is how it would work if you needed to solve for all values. In this case, it was degrees. In the next example, we'll use radians. We'll do an all values radians example. So for this example, so the last problem, we use some identities. In this problem, what we're going to do is we're going to use some quadratic formula for some solving here. So again, I want all values, and I'm going to want them in radians. So let's look at the all values and look at the all values in the radians. I notice here this is a quadratic, right? It's all cosine and it's all 2 theta. So I can look at this as like a 2x squared minus x minus 1 equals 0, where x is cosine of 2 theta, right? Just basically sub that out for x, sub that out for x. Okay, so I can solve this using quadratic formula. A will be 2, B will be -1, C will also be -1. So let's see what cosine of 2 theta will equal. Well, that'll be negative b, so +1, plus or minus b squared, -1 squared is 1, minus 4 times a times c, all over 2 times a is 2, 2 times 2 is 4, so I'm just shortcutting a little bit. So cosine of 2 theta is going to equal 1 plus or minus 4 times 2 is 8. 8 times negative 1 is negative 8. 1 minus negative 8. This whole thing under the radical is going to turn to a 9. Square root of 9 is 3. So cosine of 2 theta is going to equal 1 plus 3, which is 4 over 4, 1. Or 1 minus 3, which is negative 2 over 4, reduce 1 half. Okay? So 2 theta then equals, where does cosine equal 1? Only at one value. It's 0. 0. Oh, and then, excuse me, I forgot we're doing an all value situation. Plus 2 pi k, okay? Or, and we're done with 1 because cosine only equals 1 at one value, it's 0. Or negative 1 half. So that would be 2 pi over 3 plus 2 pi k. And again, we're looking at the unit circle values here. So it's negative 2 pi over 3. Or, so that would be 120, 180, 240. So that is, let's see, pi over 3, 2 pi over 3, 3 pi, 4 pi over 3. Excuse my figuring out. 4 pi over 3 plus 2 pi k. So this is great, but again, we only solved for 2 theta. We need to solve for regular theta, which means I need to hit everybody with a divided by 2. And everybody's getting a divided by 2, even that 2 pi k. Divided by 2, divided by 2. So then theta, 0 divided by 2 is 0. 0 plus 2 pi k divided by 2 is just pi k. Basically all revolutions now of pi. Every multiple of pi plus 0 is theta. Or 2 pi over 3 divided by 2 is going to be pi over 3. And you can hit this again with dividing by a fraction the same as multiplying by its reciprocal. So that would give you 2 pi over 6. Reduced, that would be pi over 3. Plus 2 pi k divided by 2 again, pi k. Or 4 pi over 3, if I'm cutting that in half, that'd be 2 pi over 3 plus pi k. And now we are done. So in this example, we kind of used all the tools in our tool bag. We used quadratic formula to get our solutions. We set our 2 theta equal to our solutions in all values, so we added 2 pi k to everybody. But we don't want 2 theta, we just want regular theta, so we just went through, divided everybody by 2, and then we solved for theta, got all available values for theta in this particular example. And you can see why this is considered a level 3 problem, because there's just a lot to do. So to reiterate what we've done, we solved trig equations that involved multiple angles, involved 3x, involved 2 theta, involved 2x. We solved for the angle, and then sometimes if there was parameters, we had to blow the parameters up, and then we solved for 2 theta, and we like divided everybody by 2, brought the parameters back down, like artificially blew things up, and then brought it back. We also saw that we solved for all values, and so we took into account those revolutions, whether they were in degrees, so like plus 360, or they were in radians, plus 2 pi, plus 2 pi, and then we divided everybody by either 2 or 3, depending on what we had. And then we figured out, oh, okay, well, x is going to equal this, or oh, 1 theta is going to equal this, okay? If you have any questions, please, please, please don't hesitate to ask. I hope you guys enjoyed that video.